So this video is for folks who have a continuous predictor and response variable, and you're looking to do a linear regression type analysis. That's what we'll be doing here. The data that I have to work with are the ones I created just for this video series. And if you watched the earlier video on how to format your data, you might remember that in this particular example, we're testing this hypothesis. So we've got this new medication that's supposed to confer immortality on patients. And we're testing the hypothesis that goes, if the dose of this medication influences its effectiveness, then patients given a greater volume of the immortality medication should experience greater immortality, i.e. fewer deaths within the group, because more medication leads to a greater capacity to fix underlying mortal ailments. So it's a little bit of a silly example, but it gives us a continuous predictor variable in our dose as measured in microliters. And then we have percent survival of groups of patients given these different doses across the fake studies that we reviewed. All right, so that's what we're working with. So this technique is pretty simple. Excel has a pretty straightforward way of performing a linear regression and providing us with the statistics we need to interpret it. So I'm going to go ahead and I'm going to highlight both of these columns with the header and the data. I'm going to go up to my Insert tab. And then I want to do a scatter plot. So that's like the last little graph icon option here. So it's the one that looks like this. I wish I could blow up my menu bar so you could see better. I got these options and I want to choose this one right here. All right. So my data look like they've got a pretty tight relationship, right? Because I created them to do that. Your data probably will not be this nice and neat, but we can see how this works. So right now I've got a graph. It's got a crappy chart title that just says percent survival. We'll have some other course materials on how to actually make professional looking graph captions. So we'd want to do a caption instead of a chart title. So I generally just get rid of that by just clicking on it and hitting delete. And then I'll paste this into my whatever document, my PowerPoint, and I'll make sure I put a caption. Captions go under figures. There'll be materials on that. All right. I also have some issues in that my axis titles are not labeled at all, so I want to fix that. So notice right now I have two extra tabs up here. I have chart design and format. Note that these only appear when you've clicked on your graph somewhere. So if I'm working out in my spreadsheet out here, I don't have access to those tabs. So if you don't see those tabs, that's probably what's going on. You just need to click on the graph that you just made and they'll pop up. So under chart design, the very first button on the left is add chart elements. I want to click on that, and then the second item on that menu is axis titles. And I want both of these, so I'll start with the primary horizontal axis. So this would be my dose of immortality medication as measured in microliters. We always want to have units, right? And then I also want to add a primary vertical axis title. And this is going to be percent of group surviving at least 10 years was my metric. So it's an ugly title, but that's what it is. So I have the units in there. These are percents. It does not make sense for my graph to go up to 102. So I could mess around with my axis limit as well. I'm not going to worry about that here. Okay, so the last thing I need to do is the part that gives us the statistics that we need, and that is adding a trend line into my graph. So again, I'm going to go up to chart elements. Down near the bottom, we have the trend line option, and we just pick a nice linear trend line. And again, I fabricated these data so they've got a perfect positive relationship with each other, where as one increases, the other increases by the exact same amount with each subsequent increment. So that's my line. Real data obviously wouldn't all be on the line like that. The other thing I need to do is I need to, let's see, I'm formatting the chart area. I need to click on that line, and that gives me this format trend line menu over here. I want to click these last two things. So I want to be able to see the equation on the chart. So I do the display equation on the chart, and we can see that I actually simulated these data by saying that my percent survival was just going to be my dose plus 85. So Excel recognized my sneaky trick there. But I also want to display the R² value on the chart. You will not get an R² of 1. You will probably get something that's point something. So the way we interpret R² values is kind of similar to the way we interpret grades. So if your R² value is like a 0.9, you can think of that as sort of an A. That means there's a lot of agreement. A lot of the points are falling really close to that line. That pattern's pretty strong. That's an A+ relationship there. If your R² value is, 0.8 to 0.89, that's still a pretty good fit. That line is a pretty good description of the pattern of the relationship we see between those two variables. The 0.7 range, still pretty good. Once we get below 0.7, it kind of depends on the environment you're working on. For environmental work where we've got a lot of variables we can't control for, sometimes an R² value of like 0.6 is passable. If it gets much lower than that, then that line is not a great description of that relationship between those two variables. So that's how you interpret the R² value. So think about that with respect to your hypothesis, about how you hypothesized these two variables would relate to each other. First off is the relationship in the same direction that you hypothesized. Did you hypothesize a positive relationship, in which case great, or did you hypothesize a negative relationship and what you got was a positive relationship, in which case you've got some fun thinking to do. You can obviously see a positive versus a negative relationship in the graph in terms of which way the slope is going. You can also just look at what the sign on your x value in the equation is, right? So x is positive in this case, so I've got the positive relationship. As one variable increases, so does the other. If there's a negative number in front of the x or a negative sign, that means it's a negative relationship. So as our x value increases, our y value decreases in relation. So I think that's all my tips for how to interpret that. So if you hypothesized a positive relationship here and you got the positive relationship and your R² value means that the line is a pretty decent fit for your data, then you can go ahead and consider your hypothesis supported, which sometimes isn't as interesting as if it's not supported, because that's where the fun really starts. But that's neither here nor there. So there you have it. That's how to do the linear regression in a really simple way in Excel. And yeah, let me know if you have any questions. Thanks for watching.